I am Sababu Chaka Barashango, a fellow at the Constellations Center for Equity Computing at Georgia Institute of Technology. Our mission is to expand computing opportunities in underserved communities. A big part of my role is to facilitate educators in becoming more comfortable teaching computer science. This video will help in introducing array concepts in Java. Let's begin. If we wanted to, let's say, store 10 different items, we would have to declare 10 different variables, take such different locations in memory, and we have to keep track of those 10 different variable identifiers each time we want to use them. There's an easier way. We can use arrays, which are data structures and reference objects that allows us to keep a collection of elements of the same data type. And this only reserves one location in memory. Just remember, that in Java, the array size is fixed. So I'm going to utilize a Moncala board as an example of an array, and I'm going to utilize stones as an example of my array elements. So the first thing we're going to do is declare and instantiate an array. Remember, declaring means to create an array's reference, and then instantiating it means to actually store values in the array, thus allocating location and memory for that array. So I'm going to name my array stones, and then to declare it, you have to have the data type. So begin with the data type, which is integer. So I'm going to use int bracket representing the array, and then the name of the array, which is stones. And then to instantiate it, I'm going to use an initializer list, 3, 6, 1, 5, 3, 2, as my array element values, which corresponds to the number of stones I have in each cup of the Moncala, and then assign it to my array stones. Here is the general formula for using an initializer list. Or way two is you can actually use the Java keyword new to declare and instantiate and then assign individual values to each element position in the array. Okay, next we're going to determine the array's length. And then we're going to do that. All you have to do, I'm going to just count how many holders I have in my array. So I have 6 holders. So the length of my array is 6. The dimensions are 1 by 6 in row major, 1 row, 6 columns. And then anytime I want to access the array's length in my code, I would invoke it using the name of the array, which is stones dot length. And that will return 6 in this example. The next concept we're going to discuss is the index of an array, which is an actual element's position in the array. Just remember the index starts at 0 and ranges all the way through the array's length of -1. So in my example, I have 6 elements, but my indices range from 0 through 5. And then to access a particular element, I have to notate the array's name and the index position. So my first element is at stones bracket 0. My second element is at stones bracket 1. My last element is at stones bracket 5, or it can be represented through the code stones bracket 5. Okay, so just notice that although my first element has index 0, when I invoke Stone's bracket 1, I actually get the value of 6, not 3, because Stone's bracket 1 gives me my element at index 1, which is my second element. And then Stone's bracket 2 gives me my third element value of 1, and it's not the second element, it's the third element. However, when I invoke Stone's bracket 6, remember 6 is not part of my indices for this example, so it does not exist. Will give me an out of bounds error. We can also replace elements in an array. Even though we can't change the size, we can replace elements. So whereas my initial value, third element was 1 at stone bracket 2, I can actually assign it a new value if I have 3 more stones, and now it has a new value of 4 at stone bracket 2, which is my third element. A major concept with arrays is being able to traverse the array. That means going through each element in the array and doing something with it. We're going to do that through finding the sum. So 3 plus 6 plus 4 plus 5 plus 3 plus 2 gives me the value of 23. And the algorithm or procedure I used to get that was one, I checked to make sure that my array had some values in it. And then I declared and initialized a variable called sum, an integer variable called sum at 0. And then I use a for loop where I is going to represent, the I variable is going to represent the index, the current index. And I'm going to go all the way up into the array's length, non-inclusive. So that's why you see a less than stones dot length. And then whatever that current element value is, which is represented by stones bracket I, I'm going to add that to the previous sum total. And when I'm finally able to exit the loop, I'm going to return that last sum of value. Now, here is an example of code that corresponds to traversing an array by finding the sum. I'm going to print out the whole array first, and then you'll notice between lines 3 and 16, I actually created a method called array sum, which takes an array as of data type integer as a parameter. And you'll notice the algorithm between line 9 and 15, and then line 6, where I actually use the actual parameter value stones, which corresponds to my array stones in my Mancala board. And then here is an example of traversing an array that does not have numeric elements, but string elements. And then we're going to traverse and concatenate them so that we can get one statement from those array of strings in this example. All right. Here's the general formula for traversing an array using a for loop, as I used, and then traversing an array using an enhanced loop, as was noted in the string example. Okay. Next, we're going to use those same concepts with the one-dimensional array and apply them to two-dimensional arrays, and then locate the element at index 1, 2. So in my Mancala board again, the dimensions are going to be 2 by 6 this time, and I'm going to declare an integer array of data type integer with 2 brackets representing a two-dimensional array. And then remember, a two-dimensional array is an array of arrays. Basically, each row is an array itself. And then my second row is going to have the element values 4, 5, 5, 3, 6, and 5. All right, so with the indices, it goes row major first. So the first index is always going to represent the row. The second index is going to represent the column, which still starts at 0 as well. So to locate the element at index 1, 2, I will go to second row, which is index 1. And then I will go over to the third element in that row, which is at index 2. And then that element is 5. And here's a general formula for initializing, declaring and initializing and instantiating a two-dimensional array using the initializer list or the Java keyword new. And then here's an example of going ahead and traversing a two-dimensional array. And you'll notice between lines 20 and 31 that I used a nested loop. The outer loop represents iterating through each row, and then the inner loop represents iterating through each column of that current row. And you'll notice the sum is going to represent 48. And then the same program, just using an enhanced loop noted between lines 20 and 31, but you still come up with the final sum of 48. Here are the general formula for traversing a two-dimensional array using a for loop or an enhanced for loop. Just remember, the enhanced for loop, variable 1 is an array itself. And then here are the standards in alignment to the College Board, CSTA, and CodeHS, which is the online platform we're using. Here are some additional resources you may utilize to learn more about arrays. And we thank you for visiting us today. You may visit us at our website at constellations.gatech.edu. Email us at gtconstellations@gatech.edu, or follow us on both Twitter and Instagram at gt_CCEC. Thank you for coming. We'll see you next time. Bye-bye.